So we're going to spend one more day on multiplying polynomials because it's something that we do an awful lot. Today, though, we're going to talk about some special situations that happen when we're multiplying polynomials. So I know we talked about yesterday about some shaded area problems, and for some reason those are just a tricky one to wrap your brain around, so I wanted to do one more of those just to make sure that you are completely confident in those shaded area problems. So do this one as a warm-up. Pause your videos and give it a shot. All right, so remember, shaded area would mean the area of the big rectangle minus the area of the little rectangle, that little white one, and that will give me just the shaded region, right? So if I look for my dimensions of my big rectangle, I notice, okay, the big rectangle has a length of 10 and a width of 8. I won't have to do any adding or anything like that. They just told us exactly what they were. So the area of the big rectangle would be 10 times 8. Then I want to subtract the area of the little rectangle. Well, the little rectangle has a length of 3x and a width of 2x. So the area of that one would be 3x times 2x. Well, let's see, 10 times 8 is 80 for the area of the big one, minus the area of the small one is 3x times 2x, which would give me 6x squared. So I could just say that's my answer, 80 minus 6x squared. Or if we technically want to write it in standard form, we would do negative 6x squared, because the negative goes with that term, right, plus 80. So in standard form, that would be the answer, but you could probably leave it as 80 minus 6x squared as well. Either one would be correct. All right, so hopefully you're starting to get really confident in those shaded area problems. Area of the big one minus the area of the small one. Okay, so let's review some of the other stuff. So here again, we have a binomial times a binomial. So if you remember from yesterday, that was FOIL, right? If you remember our letters of FOIL, we had first, then we had outsides, and we had insides, and then we had lasts, right? First terms, outside terms, inside terms, last terms. But really it was just double distribute. So let's just go after it. So 3x times 3x would be my first terms. That would be 9x squared. Outsides would be 3x times negative 2, negative 6x. Notice I've distributed that 3x to both things in the second binomial. Now I'm going to distribute the 2. 2 times 3x is positive 6x this time. And then my last terms, 2 times negative 2 is negative 4. So there's my FOIL. But I do see that I have some like terms here, right? Negative 6x plus 6x. Oh, well, those cancel out. So I'm left with just 9x squared minus 4. Oh, well, that doesn't happen a lot where our things cancel out completely, but it did that time. Okay, sounds good. All right, let's take a look at number 2. Again, binomial times a binomial. So we can FOIL. A times a gives me a squared. And then I have a times positive 4 for my outsides. Would give me positive 4a. Negative 4 times a gives me negative 4a for my insides. Negative 4 times positive 4 gives me negative 16 for my last terms. Okay, oh, I see I have some like terms on this one. Positive 4a and negative 4a. Oh, those are going to cancel out, so I'm left with just a squared minus 16. So that's strange. My middle terms canceled on both of these. Take a look at those again. Look at my original problems. What do you notice about those? Well, I noticed that my first terms were exactly the same in my parentheses. My second terms were exactly the same. It was just that one was plus and one was minus. Oh, same thing over here. My first terms are exactly the same. My second terms were exactly the same, but one was plus and one was minus. When that happens, when you have that situation, the middle terms are going to cancel every single time. This is a shortcut. if you notice that's what's happening, you can shortcut your way out of the FOIL and you know what's going to happen. Take a look. What happened? I did my first term. All I have is the F and the L in FOIL, right? Firsts and lasts with a minus in between. So here's my first, here's my last, and it's always minus. Look at, there was the minus as well. First terms and last terms, and it's always minus. So this is what we call the difference of two squares shortcut. Dots. We really refer to it as dots all the time. Dots, the difference of two squares says this. If you have a situation where you have a plus b times a minus b, right? Same first terms, same second terms, 1 plus, 1 minus. If you are multiplying those, you will get a squared minus b squared, right? First, last, minus in between. So the reason that we call this the difference of two squares is because of our answer, right? Difference means subtraction. And notice it says two squares, meaning perfect squares, because it's a squared and b squared. Both of these are perfect squares. That's why we call it the difference of two squares. It's what your answer is going to look like. So a plus b times a minus b gives you a squared minus b squared. Now this is a shortcut that you can use. If you notice that you have the dot situation like we do here in number 3, 2x plus 5, 2x minus 5. Same first term, same second term, 1 plus, 1 minus. I don't have to do the whole FOIL. All I have to do is say, whoa, this is dots. I say, okay, what is a squared? Well, that would be 4x squared. What is b squared? That'd be 25, and it's gotta be subtraction. 4x squared minus 25, using the shortcut, that's all I've gotta do. Now, you know, we practiced a whole bunch yesterday that the middle terms did not cancel out, right? So you have to make sure that it's dots before you use that shortcut, because if it's not actually dots, if they were both plus, or if it was not the same terms, 2x plus 5 and 2x plus 10, you would not get middle terms that cancel out, so you'd get the wrong answer if you use the shortcut when you're not supposed to. When in doubt, you can always use FOIL. It will always work, just like we saw in the last two problems. These were dots, but we used FOIL, and we got the same answer. So if you're not sure about it, you can always just FOIL. But if you want to start using some shortcuts, here's one that you can use. The dots shortcut is the first one. All right, let's see what we've got next here. Oh, number 4, a plus 5 squared. Oh, so this is something we haven't quite seen yet. Okay, well, let's see. First instinct, what I'm sure that you want to do right now is say, okay, I have an exponent outside of parentheses, so I probably want to distribute that exponent, right? So you probably think, okay, if I distribute the exponent, this would give me a squared, and this would give me positive 25. Let's see, though. What does something squared actually mean? Something squared, I'm just going to change the color on this really quick. Something squared actually means a number times itself, right? So in this case, when I say a plus 5 squared, it really means a plus 5 times a plus 5. Oh, that's a binomial times a binomial. So this really means to FOIL. So let's see, I would have to do first terms, which would give me a squared, okay. Then I would have to do outsides, which would give me positive 5a. Have to do insides, which would also give me positive 5a. And then I'd have to do lasts, which would give me positive 25. Hey, look at both those middle terms are both positive 5a. They don't cancel, they combine, and I get a squared plus 10a plus 25. And I know that that has to be right because something squared means times itself, which means FOIL. So that means that this does not work. I cannot distribute the exponent. Now you're probably thinking, wait a second, we spent whole units distributing an exponent. But if you think back to that unit 5 when we talked, or unit 4 even, when we talked about exponents, we said that it was the power of a product, meaning it had to be multiplication inside the parentheses. In this case, I have adding. So the reason that this doesn't work is because I have more than one term inside my parentheses. This is a binomial. I've got a plus or a minus going on in there. Now, if you think back to all the other ones when I distributed my exponent, it was a monomial. There might have been more than one variable I was distributing to, but they were all one term. There was no plus or minus inside those parentheses. So if we have a binomial or a trinomial or something crazy like that, if you have more than one term in your parentheses, there's a plus or a minus in there, you cannot distribute the exponent. You have to FOIL, okay? So if I look at number 5 here, 2x minus 5y in parentheses squared. So again, I cannot distribute my exponent because I've got that subtraction. This is a binomial, so instead, I'd write it 2x minus 5y times 2x minus 5y. Now, some of you may be thinking, wait, is that the dots shortcut? The first term and the second term are both the same, but be careful. Remember, for this, one has to be plus and one has to be minus. In this case, they're both the same. And so that middle term does not cancel out on these, which we saw when we actually FOILed it out the last time, right? And we'll see again. So this is not dots. All right, let's distribute. Let's do our FOIL. 4x squared for my first term. Outsides would give me negative 10xy. All right, insides, negative 5y times 2x again, negative 10. Now, you could write yx here, right? Technically, the y came first and then the x. But remember, we usually like to write our variables in alphabetical order. The reason I say that is because if you looked at these two terms, you might be wanting to tell me that those are not like terms. One's xy and one's yx. But notice they both have an x, they both have a y, both variables are to the first power. Those are like terms. So I highly recommend that if you are multiplying two terms together and you have two variables, write them in alphabetical order every time, and it'll be a lot easier to tell when you have like terms or not. Negative 10xy, negative 10xy. And then my last negative 5y times negative 5y is positive 25y squared. Now I'll notice in this one, my two middle terms are like terms. Again, I can combine those. That would give me negative 20xy. Bring my first term down. I have 4x squared. Bring my last term down. I have positive 25y squared. Okay, so can't distribute the exponent, have to FOIL. But actually, that's kind of a shortcut too. Did you notice when I was doing these? I multiply my first terms, which was really like squaring that first term because they're exactly the same. My two middle terms were always the same number. So then I added them together. And then my second terms I squared because they were the same thing as well. So my middle terms was just like multiplying the two terms together, and then I doubled it, right? A squared, 5 times a is 5a, double it gives me 10a, and then 5 squared. 2x squared, 2x times negative 5, and then I double it, gives me negative 20xy. And then negative 5y squared gives me positive 25y squared. It is a pattern. Now, this one is a lot harder to see. So I would say this is absolutely going to be only sometimes kind of shortcut. For those of you who are really feeling confident, you love finding patterns and things, and you're really good at spotting it, then you can use this shortcut. For most of us, though, we're probably just going to FOIL it out, and that's fine. But since there is a pattern, this is a shortcut. This is what we call the binomial squared shortcut, or bin squared for short. So the binomial squared shortcut says that if I have a binomial squared, a plus b squared. The shortcut says I'll square the first term, and then for my middle term, I will multiply the two terms together, a times b, and then I would double it, so 2ab. And then my third term would be b squared. All right, so there's my binomial squared shortcut. A plus b in parentheses squared would mean a squared plus 2ab, meaning multiply the two terms together and double it, plus b squared. So I want to show you what it would look like if I used that shortcut here on number 6. So if I use the bin squared shortcut, what I would get was, here's a, right? And here's b. b is -2, right? Since it's a plus b, that negative must be part of b. So if a is 3x, then a squared would be 9x squared, right? I square both parts here. Now the middle term is 2ab, meaning I would take 3x times -2. I'd get -6x, and then I double it, which would give me -12x. Now you definitely do not have to write this part out up here that I just did. This is all mental math. This is kind of my thought bubble. All right, you don't have to write that out. If it helps you, you can, but really the idea of the shortcut is that you're doing these in your head. So I was just showing you on the screen what I would be doing in my head and where that -12x came from. A, B, so multiply the two terms together and then double it. And then my third term was b squared. -2 squared gives me +4. Remember, when you're squaring something, your answer is always positive. So this right here is always going to be a plus sign. This one right here, if you have a negative in there, when you multiply them together and double it, you're going to have a negative in your answer. If that's a plus up there, when you multiply it and double it, you're going to have a plus in your answer. But that last term is squared, so that last one is always going to be a plus sign. So notice I didn't have to write out the two parentheses. I didn't have to show my FOIL and then add the two middle terms. If you use your bin squared shortcut, then you're done. But it's a tough one to see and a tough one to get right. So I understand if you're just going to write it out in FOIL, that's perfectly fine as well. All right, so just some more practice, right? Multiplying our polynomials, using that FOIL, combining like terms, write your answers in standard form. And if you'd like to use the shortcuts, binomial squared shortcut, a plus b in parentheses squared equals a squared plus 2ab plus b squared. And if you'd like to use the dots shortcut, a plus b times a minus b would be a squared minus b squared. So at this point, from here on out, if you'd like to use one of those shortcuts, you are absolutely welcome to do that on homework, on quizzes, on tests. You can use those shortcuts, but be sure it's the shortcut and use them right. And if you're not sure, just FOIL.